It's really kind of amazing when you think about it, how much machine learning is just like everywhere these days.
Yeah.
I mean, seriously, it's like from those, recommendations that pop up when you're, shopping online to like totally groundbreaking stuff happening in medicine.
Right.
It's a pretty huge deal, clearly.
That's absolutely.
So for today's deep dive, we're going to like really get into, the fundamentals of machine learning.
Okay. Sounds good.
And, the really cool thing is we've got all this incredible information from an interview with like a real pro in machine learning.
Oh, wow.
So our goal today is to, make this stuff clear and easy to understand for, you, our listeners, like what exactly is machine learning? What are the different ways it works?
Right.
The core ideas behind it. And even, how someone who's like totally new to this could start exploring it themselves.
Oh.
No like crazy jargon or anything, just like
Yeah.
a solid grasp of the essentials from someone who, really knows this stuff. So to like kick things off, what is machine learning at its core?
Well, I think what makes machine learning so like transformative is that instead of us, humans having to like spell out every single step for a computer to solve a problem,
Right.
we can actually enable the computer to learn from the data itself.
Mm.
So it's about building systems that can, find patterns,
Yeah.
draw conclusions, make predictions or decisions, and do it all with like amazing accuracy and efficiency,
Okay.
often at a scale that like humans could never do on their own.
Right. Yeah, that makes sense.
Think about how personalized your online experiences have become, right?
Totally. Yeah.
Or all the advances in self-driving cars. I mean, machine learning is like the engine behind so much of that.
That makes a lot of sense. It's like showing a computer rather than telling it.
Exactly.
Now, I know there's not just like one type of machine learning,
Yeah.
right? Like there are different approaches.
Right.
And we kind of break those down.
Yeah, definitely. The interview we looked at actually highlighted 3 main ways these systems learn. The first one is supervised learning, and you can think of it like having a tutor who gives you both the question and the answer as you're learning.
Okay.
So in this type of machine learning, the algorithms are trained using data sets that are already labeled. So for every piece of input data, we know the correct output.
Okay, so like if we wanted to teach a computer to like, tell the difference between apples and oranges.
Right.
You'd show it like tons of pictures of apples and say apple and tons of pictures of oranges and say orange.
Exactly. That's a perfect example of image classification.
Okay.
The interview also mentions stuff like spam detection,
Right.
where emails are tagged as either spam or not spam, or like predicting how much a house will sell for based on its size, location, past sales of similar houses.
Mhm.
And in that case, the past sales data with their known prices are the labels.
Okay.
Even in healthcare, supervised learning can help diagnose diseases by training on patient data where we already know the diagnosis. So it's interesting how many different kinds of problems fit into this, learning with a teacher model.
Yeah. That's really cool.
Yeah.
So what are like some of the, main tools or methods that these supervised learning systems use?
Well, the interview covered a bunch of important algorithms,
Yeah.
like for predicting continuous values. Like that house price we were talking about, there's linear regression.
Right.
Then for those like yes or no questions,
Okay.
like is this email spam or not spam,
Yeah.
we use logistic regression.
Okay.
And then you've got support vector machines, SVMs, which are super powerful for separating different categories of data.
Yeah.
You've got decision trees, which make predictions based on, series of questions.
Okay.
Random forests, which combine a lot of decision trees to get more reliable results.
Mm.
Naive Bayes, K-nearest neighbors,
Oh, yeah. I've heard of KNN.
which classifies things based on what its like closest neighbors are. And then, of course, neural networks, which are really good at finding complex patterns in data.
Right. Cool. So that's like a good rundown of supervised learning.
Yeah.
So the second type is unsupervised learning, right?
Right.
And that sounds like the computer's more on its own,
Yeah, that's a great way to put it.
figuring things out.
In unsupervised learning, the algorithm gets data that doesn't have any labels.
Whoa, wow.
So there's no right answer given during training.
Okay.
Instead, the algorithm has to find hidden structures, groupings, or relationships in the data all by itself.
So it's just like given this like pile of data and it's got to figure it out.
Yeah.
Where would that be useful in the real world?
Well, think about a company trying to understand their customers better, right?
Okay. Yeah.
They might have tons of data on like purchasing habits, website activity demographics, but no predefined customer segments. So unsupervised learning can analyze that data and automatically find clusters of customers with similar behaviors.
Oh, that's cool.
Another big application is anomaly detection, which is like spotting those unusual data points that could mean fraud, a manufacturing defect, or even a cyber attack.
Right, like red flag.
Exactly. Like imagine a network monitoring system trying to find unusual traffic patterns that just don't fit the norm.
That's really cool.
Then there's dimensionality reduction,
Okay.
where you take complex data with lots of variables and simplify it,
Right.
but you still keep the most important information.
Okay.
And in things like natural language processing, topic modeling uses unsupervised learning to automatically discover the main themes in a huge collection of documents.
So it's like the computer's doing its own exploring and having those aha moments.
Exactly. Yeah.
So what are some of the algorithms that, make that exploration happen?
Well, the interview mentioned k-means clustering and hierarchical clustering, which are both ways to group similar data points together.
Okay.
Principal component analysis, or PCA,
Right, PCA.
and independent component analysis, ICA.
Okay,
Those are techniques for reducing the complexity of data.
got it.
Then you've got association rule mining. Okay. And algorithms like a priori, which can discover relationships between different items. That's often used for things like recommending products based on what else is in your shopping cart.
Oh, that's cool. Yeah.
And lastly, autoencoders, which are a type of neural network that learns to represent data efficiently,
Okay.
often used for anomaly detection or dimensionality reduction.
So that's two types of machine learning down.
Yeah.
The third one is reinforcement learning.
Right.
This one always feels like the most sci-fi to me, like computers learning by interacting with the world.
Yeah, that's a pretty accurate image.
Yeah.
Reinforcement learning, or RL, involves an agent that interacts with an environment.
Okay.
The agent takes actions, and based on those actions, it gets rewards or penalties from the environment.
Okay.
Over time, the agent learns a policy, which is basically a strategy for choosing actions that'll get it the most rewards.
So it's like trial and error,
Exactly.
kind of like how we learn.
Just like us.
So it's like teaching a robot to walk. You reward it when it takes a step in the right direction and maybe, penalize it when it falls over.
Exactly. The interview talked about examples like training robots for complex tasks in manufacturing,
Okay.
developing AI that can play games way better than humans.
Like those game-playing AIs we see all the time.
Exactly.
Yes.
Figuring out the best way to allocate resources in a system. And one of the most ambitious applications, of course, self-driving cars.
Oh, wow. Yeah, that's a big one.
Yeah.
So what are some of the core ideas and algorithms in reinforcement learning?
Well, the interview really emphasized a few key things.
Okay.
You've got the agent, the environment it operates in,
Right.
the actions the agent can take, and the rewards it gets.
Okay.
The idea of a policy which guides the agent's decisions is really central.
Uh-huh.
And then you have algorithms like Q-learning and deep Q networks, or DQNs,
Oh, yeah.
which help the agent figure out the value of taking specific actions in different situations. And there are also policy gradient methods, which try to directly learn the best policy for the agent to follow.
So that was a really good overview of the different ways machines can learn.
Right.
Now let's get into some of the, really fundamental algorithms that are used.
Okay.
The interview mentioned a few that are super important.
Yeah.
Can we talk about, why they're so significant?
Definitely these algorithms are really like the building blocks of a lot of what we see in machine learning.
Okay.
Linear regression, like we talked about, is really important for understanding and modeling linear relationships in data,
Okay.
which is often like the starting point for a lot of predictive tasks.
Makes sense.
Logistic regression is essential for any problem where you need to predict a yes or no outcome.
Right.
Decision trees are really valuable because they create models that are super easy to understand.
Okay.
You can actually trace the logic the model uses to make a decision.
Mm-hmm.
Random forests build on that idea by using a bunch of decision trees together, which often makes the predictions much more accurate and reliable.
Cool.
Support vector machines are especially powerful when you're dealing with complex data sets that have a lot of features,
Okay.
because they try to find the absolute best way to separate different categories of data. K-nearest neighbors is a simple but surprisingly effective algorithm for classification.
Yeah.
It's based on the idea that similar things are usually close to each other.
That makes sense.
K-means clustering is another widely used technique for automatically grouping data that doesn't have labels into distinct clusters.
Okay.
Principal component analysis, or PCA, is crucial for simplifying data that has a lot of dimensions while still keeping as much important information as possible.
Right.
And then, of course, neural networks are like the foundation of deep learning.
Right.
They let us tackle really complex tasks, like understanding natural language and recognizing images with incredible accuracy.
So that was a great overview of some of those like foundational tools in machine learning. Yeah. Now, for someone listening who's thinking, this sounds really cool, how do I learn more?
Right.
What are some good resources for learning based on the interview?
Well, the person we interviewed suggested two really great resources.
Okay, awesome. Let's hear them.
The first one is a book called Hands-on Machine Learning with Scikit-learn Keras and TensorFlow by Aurélien Géron.
Okay.
It's really well respected for its practical approach.
Okay.
It shows you how to take those theoretical concepts we've been talking about and actually implement them using Python,
Cool.
which is the main programming language in this field.
Right, Python.
So it's all about getting your hands dirty with code.
Yeah, that's awesome.
The second recommendation was Udacity's Machine Learning Engineer Nano degree.
Okay, I've heard of Udacity.
It's a more structured online program.
Okay.
It's got video lectures, interactive exercises, real-world projects, and it even has mentorship.
Oh, wow. That's cool.
It's meant to be like a really comprehensive learning experience to help you build a strong portfolio of projects, which is super important when you're trying to get a job in this field.
Right, yeah, that makes a lot of sense.
Yeah.
Those sound like really great places to start.
Absolutely.
Now, let's say someone is like super serious about a career in machine learning.
Okay.
The interview we've been talking about actually laid out a pretty detailed path.
Right.
Can we break down some of those key areas?
Definitely the interviewee really stressed the importance of building a strong mathematical foundation.
Right, it's not just about like memorizing formulas.
No, it's about really understanding the concepts.
Right.
So for linear algebra, that means getting comfortable with matrix operations.
Okay.
Understanding techniques like singular value decomposition or SVD, which is used for simplifying data,
Right.
eigenvalues, and tensor calculus, which is especially important if you're working with deep learning frameworks like PyTorch. For calculus and optimization, the focus should be on gradients, Jacobians, and Lagrangian multipliers.
Okay.
That helps you really get how algorithms like backpropagation work in neural networks and the whole idea of loss landscapes.
Okay.
And for probability and statistics, it's important to dive into Bayesian inference Markov chain, Monte Carlo methods, or MCMC and hypothesis testing, maybe using tools like PyMC3 or STAN.
So it's not enough to just use the tools. You got to understand like the math behind them.
Exactly.
Okay, so what's the next step in this journey?
The next big thing is mastering programming and all the essential tools. You absolutely need strong Python skills.
Okay.
And that means going beyond the basics.
Right.
The interviewee talked about learning about decorators, generators, and parallel processing to write code that's more efficient and scalable. And then there's the specific tools used in machine learning.
Right.
Jupyter Notebooks for experimenting, Git and GitHub for managing code and working with others, and Docker for creating consistent environments for your projects. And knowing about cloud platforms like AWS SageMaker, Google AI Platform, or Azure ML is really important for understanding how to deploy machine learning models in real-world applications.
Okay, so a solid base in math, strong programming skills.
Exactly.
What about getting a deeper understanding of how the algorithms themselves work?
Right, so that's about developing algorithmic depth and intuition.
Okay.
The interviewee said it's not enough to just know how to use the libraries. You should also try to understand how the core algorithms work.
Right.
And even try implementing them yourself from scratch.
Wow, yeah, that's going deep.
For supervised learning, this might mean coding the dual formulation of support vector machines,
Okay.
or implementing gradient-boosted trees like XGBoost. For unsupervised learning, exploring techniques like Gaussian mixture models, using the expectation maximization algorithm, and becoming good at data visualization techniques like TSNE are key.
Okay.
And for reinforcement learning, it's about working with environments like OpenAI Gym, and understanding more advanced things like policy gradients and proximal policy optimization.
So really getting into the nitty-gritty of how these learning systems work.
Exactly.
So what comes next in terms of practical preparation?
Well, data mastery is the next big step.
Okay.
This is more than just cleaning data.
Right.
It's about really understanding how to process it to get the best results from your models. The interviewee mentioned automating those pre-processing steps using tools like Scikit-learn's column transformer for things like handling missing data,
Right.
scaling numerical features, and encoding categorical variables.
Okay.
Feature engineering is another important skill.
Right.
Using your knowledge of the data and the problem to create new features that can improve how well your model performs.
Okay.
Like using Fourier transforms for time series data or word embeddings for natural language processing. And for dealing with really huge data sets, knowing big data tools like Spark ML Lib or Dask is becoming more and more important.
So data is like the fuel for machine learning.
Exactly.
What about the specific software libraries and frameworks that people use in the field?
Yeah, gaining expertise in those is super important for actually doing machine learning.
Okay.
For classic machine learning tasks, scikit-learn is like the go-to library for building model pipelines, doing hyperparameter tuning with tools like grid search CV, and creating your own data transformations. For deep learning, TensorFlow and PyTorch are the big players.
Right. I've heard of those.
TensorFlow is often preferred for deploying models in production environments,
Oh,
while PyTorch is really popular in research.
got it.
Knowing about transformer architectures through libraries like Hugging Face
Okay.
and graph neural networks using libraries like DGL is also becoming more valuable. And finally, mastering data visualization tools like Plotly
Okay.
and techniques for understanding your models like SHAP lets you communicate your findings effectively.
So basically, you need a whole toolbox of specialized software skills.
Right.
So what about proving your skills to potential employers or collaborators?
Well, that's where executing projects with a purpose comes in.
Okay.
The interviewee said it's really important to build a portfolio of complete systems that show off your skills.
That makes sense.
They gave examples like deploying a sentiment analysis API using a BERT model, optimizing deep learning models for efficiency on specific hardware, or building a collaborative filtering recommendation system.
Cool.
Contributing to open source projects like finding and fixing bugs in TensorFlow, or adding new features to PyTorch Lightning is also a great way to show your skills and learn from experienced people.
So getting that real-world experience is key.
Exactly.
What else is important for someone trying to break into this field?
Well, being active in the machine learning community and the broader industry is really important.
Yeah.
This includes participating in competitions on platforms like Kaggle or Driven Data,
I've heard of Kaggle.
where you can test your skills on real problems and learn from how other people approach them.
Cool.
Contributing to online discussions, writing blog posts about interesting research papers, or even presenting your work at meetups. All of that can help you learn more and share what you know.
So staying connected and sharing is really important.
Absolutely.
Finally, the interview talked about staying ahead of the curve.
Right.
How can someone keep up in such a fast-moving field?
Well, you have to keep learning.
Right.
Regularly reading research papers on platforms like Arcs of Sanity can help you stay updated on the latest breakthroughs.
Okay.
Things like generative models or efficient neural network architectures, getting relevant certifications,
Okay.
like the TensorFlow developer or AWS ML specialty certifications,
Right.
and going to leading conferences like NeurIPS or ICML are also valuable for networking and staying on top of the latest advancements.
So always be learning.
Exactly.
Okay, so we've gotten a really comprehensive roadmap for anyone serious about a machine learning career.
Definitely.
Now, to wrap things up, the interviewee gave some key advice for people who are just starting out.
Right.
Can we go over those main takeaways?
For sure, they emphasized 3 main pillars for success.
Okay, what's the first one?
The first is theoretical rigor.
Okay.
It's not enough to just know how to use the tools.
Right.
You need a deep understanding of the underlying math and principles,
Okay.
like being able to derive backpropagation yourself,
Right.
understanding how a GPT-2 tokenizer works, and having a good grasp of the bias-variance trade-off.
So really understanding the how and why.
Exactly. That deep understanding lets you really know how your models work,
Right.
figure out problems, and adapt to new situations.
That makes sense.
The second pillar is operational excellence, which is often called MLOps.
Okay, MLO.
This is about developing the skills to build reliable and scalable machine learning systems.
Okay.
This means setting up continuous integration and continuous deployment pipelines,
Right.
implementing robust monitoring systems, and understanding cost optimization strategies for deploying models in the cloud.
Makes sense.
The interviewee said that even the most innovative models are only useful if they can be deployed and maintained effectively in the real world.
So it's not just about making the model, it's about making it work.
Exactly.
That's the final pillar.
The final pillar is strategic context and community engagement.
Okay.
This is about knowing how machine learning can solve real-world problems,
Right.
aligning your projects with meaningful goals, and being an active part of the machine learning community.
Makes sense.
They encouraged what they called learning in public,
Oh, yeah.
sharing your journey, your challenges, and what you learn with others.
Right.
They also talked about the importance of understanding how your models affect key performance indicators in the real world.
Right. Like, does it actually work?
Yeah, things like the accuracy of a fraud detection system
Okay.
or how well a medical imaging tool can diagnose things.
So it's not just about building cool algorithms.
Right.
It's about using them to solve real problems responsibly
Exactly.
and working with others.
Yeah, definitely.
The interviewee's final thought was really interesting.
What was it?
They said that ultimately machine learning is about solving human problems.
That's a good point.
Whether it's finding more efficient ways to process information on mobile devices or using satellite imagery to monitor climate change,
Right.
the goal should be to make a positive impact.
I like that.
It's about embracing complexity, being curious, and always striving to learn more.
That's a really inspiring way to look at it.
This deep dive has been incredibly informative.
It has.
To recap, we've talked about what machine learning is all about, computers learning from data.
Right.
We looked at the three main types: supervised, unsupervised, and reinforcement learning, each with its own set of powerful algorithms.
Yeah.
We even got a really detailed roadmap for anyone who wants to learn more and maybe even have a career in this field.
Yeah, I think what's really cool about the interview is that it gives us not just like a general overview,
Right.
but also really specific advice for anyone who wants to understand or work in machine learning.
Yeah.
It highlights how important it is to have both theoretical knowledge and practical skills, and to really focus on solving real-world problems.
Totally. It's clear that becoming good at machine learning takes a lot of work.
It does.
But hopefully this deep dive has given you, our listener, a solid understanding of the main concepts
Right.
and a good place to start if you want to learn more.
Yeah, definitely.
So here's a final thought for you to think about.
Okay.
As machines get better and better at learning and solving problems on their own,
Yeah,
how will that change not just industries,
right.
but also our daily lives in ways we can't even imagine yet?
That's a great question.
And what role will you play in shaping that future? We encourage you to explore the algorithms or applications that you found interesting today.
Absolutely.
Thanks for joining us on this deep dive.
Yeah, thanks for listening, everyone.
See you next time.